So now we're going to turn our attention to the order in which results can be provided. And I'll give you an overview of this first, and then we'll take a look at how different kinds of aggregate operations, how different kinds of terminal operations, how different kinds of collections, how different kinds of intermediate operations can influence the order in which things are returned. So as I mentioned before, the order of the results in a parallel stream is much more deterministic, or can be much more deterministic than the order of processing, which is inherently non-deterministic. So you can take control over this. And in particular, the way in which you can control the order is you can indicate through various means, as we'll see, whether or not the results that come back will be presented in so-called encounter order. And this term encounter order seems a little weird at first, but really all it means is if you have some kind of ordered collection that's your data source, like an array list, for example, where there's an ordering. There's the 0th location comes before the first location, comes before the second location, comes before the third location, and so on. So in that case, there's an inherent encounter order. That's the order in which you would encounter the elements in the collection if you, for example, were to iterate through it, or you put it in there by doing an add or something that would be ordered. Remember, ordered, by the way, is not the same as sorted. It just means it's in some order from beginning to end. So you can dictate whether or not you want the results to come back in the same order that they were encountered in the original data source. And so we'll talk about how that works. So the encounter order is the order in which the stream source makes its elements available. That's basically encounter order in a nutshell. So encounter order will be maintained under certain circumstances. For example, if the data source is ordered, and the aggregate operations that are used to process that data source are also obliged to maintain that order. And to think about this, if you go back a number of weeks, we had a video that talked about how sequential streams worked under the hood. And for this part of the discussion, it works the same for parallel streams. And I talked about the fact that different kinds of data sources had different characteristics or different flags, things like is it ordered? Is it sorted? Is it sized? And so on and so forth. Are there duplicates that are allowed? And so on. And those properties are used to do the assessment to determine whether the output needs to be maintained in encounter order when you get the results back. Now, what's interesting about this is the semantics are the same here, whether or not the stream is run in parallel or sequentially. And so if you have a parallel stream and the encounter order is maintained, then even though the different processing may take place on the different elements, the different chunks in different orders, the results will come back in the encounter order. And that's true semantically, whether it's a sequential stream or a parallel stream. And I guess it's kind of like, you may have two different systems of measurement. You may have metric, you may have imperial, but the distances will be the same. It's just that the representations will be different. So a mile or miles per hour will be different for kilometers per hour, but it's the same speed. So you get the same results. It's just represented in a different way. The main difference between maintaining and not maintaining encounter order, however, manifests itself in terms of performance. So as a general rule of thumb, as a rule, things that are going to preserve encounter order are often going to be a little slower than things that don't care about preserving encounter order. Now, sometimes it doesn't matter, but in other cases it does matter. So if you don't really care about encounter order and you just want to be able to have things run non-deterministically and then produce the results in whatever order they happen to finish in, then you need to take some explicit steps to tell the system, I don't care about encounter order, and therefore don't go to any heroic lengths to try to maintain it. And we'll see specifically how you can do that here and what the consequences are in terms of performance. So again, that's just a quick overview of the concept of ordering the results, and encounter order is the primary way in which you can take control over the result order. So as we'll see shortly when we look at the details and look through some examples, when encounter order is required or encounter order is enabled, then you'll get back the results in encounter order, which will be the same whether it's parallel or sequential, but the performance may be a little slower if you dictate the use of encounter order, because extra work has to be done to arrange the results in a way that will be ordered by the order in which the data source presented them.